This video will cover questions relating to the topic of optimization problems. Inscribe the rectangle. Question 1. When looking for an equation in such a question, it is best to use the most basic one without transformation. It is usually assumed that the center is at the origin. The equation for a circle with a center at the origin and radius of 4 is x squared plus y squared equals 4 squared. Then y squared equals 16 minus x squared. Y equals plus minus square root of 16 minus x squared. The rectangle is inscribed in the semicircle. Let this point in quadrant 1 be x, y. A semicircle has an equation y equals square root of 16 minus x squared. The area of the rectangle is 2x times y equals 2x times y is square root of 16 minus x squared. So we maximize a of x equals 2x times square root of 16 minus x squared. Use the product rule. Fg prime equals f prime g plus fg prime. Then a prime of x equals 2x prime times square root of 16 minus x squared plus 2x times square root of 16 minus x squared prime equals 2 times the square root of 16 minus x squared plus 2x times square root of x prime equals x to the power of 1 over 2 prime equals 1 over 2x to the power of minus 1 over 2. We can rewrite as 1 over 2 square root of x. Now using the chain rule, d dx of square root of u equals 1 over 2 square root of u times u prime. Then back to the original, 1 over 2 square root of 16 minus x squared times 16 minus x squared prime equals 2 square root of 16 minus x squared plus 2 is cancelled. X over square root of 16 minus x squared times 16 minus x squared prime is minus 2x. Then we can rewrite as 2 square root of 16 minus x squared minus 2x squared over square root of 16 minus x squared. We have to make one single fraction, so times square root of 16 minus x squared over square root of 16 minus x squared equals 2 times 16 minus x squared minus 2x squared over square root of 16 minus x squared. Expand 32 minus 2x squared minus 2x squared over square root of 16 minus x squared equals 32 minus 4x squared over square root of 16 minus x squared. To find the critical numbers, we equate the derivative to 0. So 32 minus 4x squared equals 0. Then minus 4x squared equals minus 32. Then x squared equals 8. That means x equals plus minus 2 square root of 2. Or derivative does not exist. That means 16 minus x squared equals 0. Minus x squared equals minus 16. Then x squared equals 16. That means x equals plus minus 4. But the domain of this function is x is between 0 and 4. That means x equals 2 square root of 2. Since the point is in quadrant 1, the domain is greater than 0, less than 4. The number line is here between 0 and 4. Then a prime of x, the number 2 square root of 2 is here. The testing number is 1. The denominator is always positive, So we can check the numerator. So 32 minus 4 times 1 squared equals 32 minus 4, which is 28, is always greater than 0. When the testing number is 3, then 32 minus 4 times 3 squared equals minus 4, which is less than 0. A prime changes from increasing to decreasing at x equals 2 square root of 2. Now we verify that x equals 2 square root of 2 gives an absolute maximum value for a. Y equals square root of 16 minus x squared. When x equals 2 square root of 2, then y of 2 square root of 2 equals square root of 16 minus 2 square root of 2 squared equals square root of 16 minus 8, that means square root of 8, which is 2 square root of 2. A is 2 times x times y, then a equals 2 times x is 2 square root of 2, then y is 2 square root of 2. The final answer is 16. So the maximum area is 16. Question 2. Here is y equals 6 minus x squared. X-intercepts are minus square root of 6, square root of 6. A rectangle is here. The upper right vertex of the rectangle is here. Let's say x, y, where x is between 0 and square root of 6. Since the point is in quadrant 1, the rectangle has area a of x equals 2 times x times y. We can rewrite as 2x times y is 6 minus x squared. Then expand 12x minus 2x cubed. Then a prime of x equals 12 minus 6x squared. To find the critical numbers, we equate the derivative to 0. So 12 minus 6x squared equals 0. Then minus 6x squared equals minus 12. Then x squared equals 2. That means x equals square root of 2 or minus square root of 2. But this one is a reject because x is between 0 and square root of 6. The number line is here, 0 and square root of 6. A prime of x square root of 2. When the testing number is x equals 1, a prime of 1 equals 12 minus 6 times 1 squared, which is 6 greater than 0. When the testing number is 2, a prime of 2 equals 12 minus 6 times 2 squared equals 12 minus 6 times 4, 24 equals minus 12 less than 0. A prime changes from increasing to decreasing at x equals square root of 2. Now we verify that x equals square root of 2 gives an absolute maximum value of a. Y equals 6 minus x squared. When x equals square root of 2, y of square root of 2 equals 6 minus square root of 2 squared. Then 6 minus 2, which is 4. A of x is 2xy, then a of square root of 2 equals 2 times x is square root of 2, then y is 4. That means a square root of 2. The largest area is a square root of 2. The largest area is when the point is square root of 2, 4. Then means the base is 2 square root of 2. The height is 4. The dimensions are 2 square root of 2 by 4. Question 3. Here is x squared over a squared plus y squared over b squared equals 1. An inscribed rectangle is here. The upper right vertex of the rectangle is here. Let's say x, y, where x is between 0 and a. This one is x. The length of the rectangle is 2x. Then this one is y. Then width of the rectangle is 2y. So a equals 2x times 2y, which is 4xy. We want to express a as a function of just one variable, so we eliminate y in terms of x. So from here, y squared over b squared equals 1 minus x squared over a squared. Then y squared over b squared equals, make a single fraction, a squared minus x squared over a squared. Then times b squared on each side, y squared equals b squared times a squared minus x squared over a squared. Y equals b over a times square root of a squared minus x squared, or minus b over a times square root of a squared minus x squared. Since the point we picked here is above the x-axis, the equation take the positive part of the x-axis. Not this one. Then back to the original. A of x equals 4x times y is b over a times square root of a squared minus x squared. So we maximize a of x equals 4b over ax times the square root of a squared minus x squared. Then a prime of x equals 4b of ax prime times the square root of a squared minus x squared plus 4b of ax times square root of a squared minus x squared prime equals 4b over a times square root of a squared minus x squared plus 4b over ax d dx of square root of x equals 1 over 2 square root of x. Then d dx of square root of u equals 1 over 2 square root of u times u prime. Then back to the original, 1 over 2 square root of a squared minus x squared times a squared minus x squared prime equals 4b over a times square root of a squared minus x squared plus 4b over ax times 1 over 2 square root of a squared minus x squared times minus 2x equals 4b square root of a squared minus x squared over a minus 2 is cancelled, 4bx times x, 4bx squared over a square root of a squared minus x squared. We have to make a single fraction, so we need square root of a squared minus x squared over square root of a squared minus x squared equals 4b times together a squared minus x squared over a times the square root of a squared minus x squared minus 4bx squared over a times the square root of a squared minus x squared. Then make a single fraction, expand 4a squared b minus 4bx squared minus 4bx squared over a times the square root of a squared minus x squared 4a squared b minus 8bx squared over a times square root of a squared minus x squared. Then we can factor, take out 4b a squared minus 2x squared over a times square root of a squared minus x squared. To find the critical numbers, equate the derivative to 0. So 4b times a squared minus 2x squared equals 0. That means a squared minus 2x squared equals 0. Minus 2x squared equals minus a squared. Then make positive. Then x squared equals a squared over 2. Then x equals a over square root of 2 or minus a over square root of 2, or the derivative does not exist. That means this part, a squared minus x squared equals 0, then minus x squared equals minus a squared, make positive, then x equals a or minus a. The domain of x is this, so x equals a over square root of 2. The number line is here, a prime of x between 0 and a. X is a over square root of 2. When the testing number is a over 2, the denominator and the numerator b are always positive, so we have to check only this part. Then a squared minus 2 times a over 2 squared equals a squared minus 2 times a squared over 4. Then a squared minus a squared over 2, a squared over 2, which is positive. When the testing number is a over 1.2, 1.2 is 12 over 10. We can rewrite as 6 over 5. That means 1 over 1.2 is upside down, 5 over 6. Then a squared minus 2 times 5a over 6 squared equals a squared minus 2 times 25a squared over 36 equals a squared minus 25a squared over 18. That means minus 7a squared over 18, which is negative. So a prime changes from increasing to decreasing at x equals a over square root of 2. Now we verify that x equals a over square root of 2 gives an absolute maximum value of a. From here, y equals b over a square root of a squared minus x squared. When x equals a over square root of 2, then y equals b over a square root of a squared minus a over square root of 2 squared, b over a times square root of a squared minus a squared over 2 equals b over a times square root of a squared over 2. Then b over a times a over square root of 2, we can rewrite as b over square root of 2. The area of the rectangle A is 4 times x times y, then 4 times x is a over square root of 2, y is b over square root of 2 equals 4 times ab over 2. The final answer is 2ab. So the maximum area is 2ab. Question 4. Here is y equals minus 1 over 3x plus 4. Y-intercept is 4. X-intercept is 12. A rectangle is here. The upper right vertex of the rectangle is here. Let's say x, y, where x is between 0 and 12. The rectangle has area. A of x equals, this one is x, this one is y, then x times y. We can rewrite as x times y equals minus 1 over 3x plus 4. We can rewrite as minus 1 over 3x squared plus 4x. Then a prime of x equals minus 2 over 3x plus 4. To find the critical numbers, we equate the derivative to 0. Minus 2 over 3x plus 4 equals 0. Minus 2 over 3x equals minus 4. Then times minus 3 over 2 on each side. That means x equals minus 4 times minus 3 over 2 equals, make positive, 2 times 1, 2 times 2, which is 6. A prime of x equals minus 2 over 3x plus 4. Then a second prime of x equals minus 2 over 3, which is always less than 0. So a is concave downward for all x. By the second derivative test, a has an absolute maximum at x equals 6. Y equals minus 1 over 3x plus 4. When x equals 6, y over 6 equals minus 1 over 3 times 6 plus 4 minus 2 plus 4, which is 2. That means a is x times y. Then x is 6, y is 2, which is 12. So the maximum area is 12. This is the last one. Here is an equilateral triangle of side S. This one is the height h, and this length is s over 2. Using the Pythagorean theorem, h squared plus s over 2 squared equals s squared. Then h squared equals s squared minus s over 2 squared, s squared minus s squared over 4. We can rewrite as 3s squared over 4. Then h equals square root of 3s over 2 or minus square root of 3 over 2s. H is positive, not this one. So h equals square root of 3s over 2. Then height is square root of 3s over 2. Here is a rectangle. If the horizontal length of the rectangle is x and the vertical length of the rectangle is y, we can compare these two triangles. The base of the small one is x. The height of the small one is square root of 3s over 2 minus y. The base of the original one is s. The height of the original one is square root of 3s over 2. Using similar triangle, square root of 3s over 2 minus y over x equals square root of 3s over 2 over s. Then cross multiply. Square root of 3s over 2 minus y times s equals square root of 3s over 2 times x. Then expand. Square root of 3s squared over 2 minus ys equals square root of 3sx over 2. Then we can rewrite as square root of 3s squared over 2 minus square root of 3sx over 2 equals ys. Then times 1 over s on each side. Square root of 3s over 2 minus square root of 3x over 2 equals y. The area of the rectangle is a of x equals x times y. Then x times y is this one. Square root of 3s over 2 minus square root of 3x over 2. Then expand. Square root of 3sx over 2 minus square root of 3x squared over 2. Then a prime of x equals square root of 3s over 2 minus square root of 3 over 2 times x squared prime is 2x. Then we can rewrite as square root of 3s over 2 minus 2 is cancelled, square root of 3x. To find the critical numbers, we equate the derivative to 0. Square root of 3s over 2 minus square root of 3x equals 0. Then minus square root of 3x equals minus square root of 3s over 2. Then make positive, cancel, x equals s over 2. From this, a second prime of x equals minus square root of 3, which is always less than 0. So a is concave downward for all x. By the second derivative test, a has an absolute maximum at x equals s over 2. Why is this one? When x equals s over 2, then y of s over 2 equals square root of 3s over 2 minus square root of 3 over 2 times x is s over 2. Then square root of 3s over 2 minus square root of 3s over 4. Then 2 square root of 3s over 4 minus square root of 3s over 4. The final answer is square root of 3s over 4. So the dimensions are s over 2 by square root of 3s over 4. I hope this video has been helpful. If you have any questions, leave them in a comment. Thank you for watching. Please like and subscribe for more.